So, this is page 464, right? Alright, so number 1, someone read that question for us?
What is
What is the density of the precipitate formed during the reaction between lead to nitrate and potassium iodide?
Okay, so we want to write this out, so I'm going to start with my lead, you said nitrate?
lead to nitrate?
Okay, lead 2 nitrate. So when we look up our charges, we know that lead is a +2, nitrate is a -1. If we're crisscross, I'll just write it up here so we can see. Crisscross, get my 2 there, equal to 0. I have to have 2 of these to make that. Okay? Then we said potassium iodide. Okay, a +1, -1, so it's equal to 0, or crisscrosses are 1s. So which ones are going to be swapped then?
Positive PB.
Okay, so what am I going to have instead?
I and
So PBI, right? We always start with our positive. And what's our other one going to be? Okay, so those 2 are swapping, right? Switching those. So I'm going to have to look at my charges to balance things, right? Lead has a +2, iodine -1, +1, -1. What do I need to do to make these happy here so far? Okay, so now my crisscross has worked, or my equal to 0. Now I need to look at it as a whole. What do I need to do to balance it? Okay, you see that? We've balanced it. Now we're going to go to our yellow sheet because we were asked what the precipitate was, right? So we're going to look up nitrate first, or iodide, whatever order. We did iodide first, so I guess we can do iodide. Let's look up iodide. KNO3.
is going to be for PBI.
So PBI, so looking up I. Which rule number is this?
6.
Okay. Do we see PB +2 as, okay, does this mean it's soluble or insoluble? Insoluble, so this means that I'm going to be making a precipitate here, right? So what I should be writing is an S there for solid, or you can write precipitate. Normally there's only 1 in an equation and you're usually done, but we're just going to double check, make sure that we didn't make any errors. We're going to look up NO3. What number is that on a rule? Okay, what do we learn about that one? Essentially all are soluble, so we have no precipitate, meaning it would still be an aqueous then, right? So we found our precipitate, we're done. That's all number 1 asked us for, right?
Why does it say what is the identity precipitate?
Just to identify which one it is. So you could either write precipitate beside it, circle it, you could write PBI2 is precipitate, whichever way you want to do it, as long as you identify that that's the one. I often circle it and write precipitate beside, so it's really obvious. So then we're going to move to number 2. Someone read that for us?
Write a balanced equation between solutions of silver nitrate and sodium chloride.
Okay, so we said silver nitrate. And what?
Sodium chloride.
Okay, so I'm going to look back and check all my charges here. When they said silver nitrate, we look it up. Nitrate is our -1. Silver has a +1. Sodium is
1.
and chlorine. Okay, so we are equal to 0 or crisscross is fine. So which 2 are going to swap for me? So my Ag and my Na, right? 2 positives. So I'm going to have AgCl, and I'm going to have to write this below. We're going to have Na and NO3. Okay, are we balanced across the board? Good. Now it asked us just to write it out, or did it ask us to find a precipitate? Just to balance it? Okay, so then I should have my ones in front to indicate that it is balanced as is. Didn't ask for precipitate, then we're gonna move forward.
Are you doing A, B, and C, or just one of them?
I'm gonna continue to do them all. If at some point you're feeling pretty comfortable and you just want to keep going on your own, then just move forward and then catch up when I get to there. So if we're looking at A, in general for these ones we're supposed to write the net ionic equation, right?
That's the line one?
No, of the short one. Net is just telling me the what and what makes the precipitate. So it's already it's written out part of it, right? If we look back, that's the exact same one that we just did, right? Right? This one here. So we already know what it looks like. So let's look them up then. So if I want you to look up chlorine, I want you to look up the nitrate, and let me know which one is going to have that.
The AgCl one.
AgCl is going to be my precipitate?
Yeah.
We agree? Okay, so because this one here is my precipitate, all that it was asking for is the net ionic. So what two ions is making that? Well, Ag is going to, it's going to have a +1, the aqueous, then I'm going to have chlorine, which is going to be a -1, again aqueous, to give me AgCl. I'm putting a little S there to indicate that it's a solid, if that's what's happening. Make sure that we have our charges, because we're talking about ions. Done. Okay?
How did we know? So that's like the one we
Right. Net ionic is just the one to give me the solid. Which ions are giving me the solid? If it asks for the ionic equation, it wants the whole thing, all the spectators and everything. Okay? So, what I do for this question, because I'm pretty good at being able to tell which ones are going together instead of writing it out. I'll just show you a shortcut for how I do it. So this is A. So we're looking at B. So when we read B, I go, it's lead 2 nitrate and potassium bromide. That means that my two front ones are positives. Those are got to be the ones that are going to switch. Okay, so what am I going to have then instead? If I just switch them right away. PB with bromine. And what's the other one? Okay, and then all I need to go back is think about charges. I know that it's a +1 and a -1, so it's fine. PB, it said that it was lead 2, right? So I have a +2 and a -1. So crisscross, my 2's got to go there. Right? So this is my quicker way of doing it instead of writing everything out. Because all they want to know is which one's making my precipitate into that short little ion thing, right? We probably realized at this point that nitrate, no matter what it hooks up with, soluble. So it's not going to be this one. We're pretty sure it's going to be this one. We're going to double check. We're going to look at bromine. We're going to look up lead. Low solubility, insoluble. This is my precipitate. So I'm just going to write it out. Eb +2, aqueous, plus Br, -1, aqueous. Going to give me Pb, Br2. That's a solid. Okay? If you can do it this way and see it right away, it's faster than writing it out, switching it, and then going back. Does that make sense? If you need to, write out the whole thing for yourself, whichever is faster. Or less likely for you to make a mistake. Can I keep going? You're still ready? Good. Okay, so I'm going to look at C. So I'm going to do the same thing. Is that okay if I shorten it up instead of writing it out? Okay, so this time we have sodium sulfate and barium chloride. So what's going to swap? My two positives. What am I going to have?
Sodium.
The other one? Okay, and then I'm going to think charges just to match up. +1, -1, +2, -2. So it should be balanced like that. I'm going to look them up. When I look up chlorine, what's up with sodium? Is it soluble or insoluble? Soluble, so that's not my one. Just make an X there. Looking at barium sulfate. Sulfate with barium. Low solubility makes my precipitate. It's gotta be that one. Ba +2. Okay, a lot of people find solubility pretty easy because all you're doing is going back to that table basically every time. So I'm going to move on to 4. 4 is just asking us to tell us if it's going to be soluble or insoluble, I believe. Okay, so I'm just going to write A, B, C, D, E, F and just keep going. And just write the answer that we come up with. So if we look at A, it's sodium hydroxide. Looking up hydroxide. Soluble. Okay, looking at B for that NH4CH3COO. CH3COO. Doing okay? We're seeing where we're looking. Find them. Okay, looking at C, calcium sulfate. So looking up sulfate. So solubility, so insoluble. Looking at D, PbCl. Okay, so insoluble again. Looking at E, KCl. Soluble. And looking at F, CaBr2.
I know I can't find it here.
Okay? I know we went through that one pretty fast, but does it make sense what we're doing? Okay. So I'm going to move on to 5 then. Remember, if you're feeling confident, you can just skip ahead of me. Just let me know. Alright, 5 is basically asking me what's a spectator on it. How can we define it?
It watches.
It watches. Okay. Yep. I would say not participating in reaction. Okay. Something to that. They remain unchanged. It just watches. We don't see it. Alright, so then 6 is asking us to write out the new ones, balance them, and then write the ionic and the net ionic. So we're doing the 2-step part here. So we're looking at 6A. Okay, so these ones here, I believe, I won't do all of them because it follows the same idea with you, but for yourself, for additional practice, you guys can do additional ones. Okay, so I'm going to start with A. We'll look at that one. And I'm going to do, I think, the ones that are circled on yours. A, D, G, and J. Okay, but doing the other ones for yourself is a good practice, okay? So 6A has sodium hydroxide with what? Sodium chloride. Okay, so which ones are my positives? Okay, so what am I going to have over here? Okay, it's important to note that when we do this one, even though we get HOH, looks like water, we don't put it into water. We still have to think of it as a hydroxide and find out what it's hooking up with. So now what I'm going to do is I need to find out which one is making me a soluble or insoluble. Alright, so we're going to look up chlorine first, because I wrote it first. Both are soluble? That's all I have. I'm going to look at that chart. So, sodium chloride, fluoride. H in the soluble? Oh, tricky one. Alrighty. So they're both aqueous, so then this one and chlorine is too. So then we can't go any further. So we have aqueous, and we said aqueous was here. So then we would have to stop because we're going to be able to make a precipitate. There's no precipitate for us to show. So. I'm going to go on to B and I'm just going to put a, or D I think is the one I said, right? So, looking at D, what's my equation starting off with this one? Cl3? Okay, so what's my going to be when they swap?
Oh wait, this is CuCl and then FeSO4.
Okay, so we need to look at chargers here. Because there's going to be some different ones going on. When I look up sulfate, what's my charge for sulfate?
-2.
It's a -2. So this is a -2. What's that copper got to be? It's got to be a 2. It's got to be a +2. If I look over here, I know that chlorine is a -1. Because we remember that 3 had to come this way, right? Because if we look up iron, it has 2 options. So we know that iron's got to be a +3. So over here, I have to have a +2 and a -1, and a +3 and a -2. So what is this one going to look like first? Okay, and what is this one going to look like? Okay, and they have to be in brackets, right? Brackets have to be there to say that the whole group is getting free. So now I need to go back and balance it. So what I do is I look for the groups that are together. So I have 3 sulfates here, but only 1 here. I'm going to put a 3 here. 3 sulfates, 3 sulfates. I have 3 coppers here, so I'm going to have to put a 3 here to make my coppers happy. Okay? Then I'm going to look at the next one. I have 1 iron, but I have 2 here. I'm going to do 2 irons, 2 irons. 2 times 3 is 6, 6 chlorine. 3 times 2 is 6, 6 chlorine. It just takes a lot of practice. Just keep walking through it. Alright. So now, for this one, we need to look them up in the end. Because remember, these are my aqueuses that I should have indicated. Now I gotta look up these 2 to find out
The CuCl.
the CuCl is what?
A low solubility.
So it's a solid. Okay? And we're just gonna double check and check out the other one. The sulfate. We got an AQ. Okay, so this one here is my solid. So for the ionic one, we gotta write the whole thing. It is a lot. So remember, you have to write each part of it. So 3UC plus the 2, right? We're gonna have to have aqueous plus, and then there are. I kind of do what's going together to make myself, but whichever way works for you. Or if you go in order, so 3SO4, the -2, and this is aqueous, plus 2 with the iron, plus 3 aqueous, plus our 6 chlorine, -1, that's aqueous. That gives me my 3 CuCl2, and that's my solids, that's why it gets to stay together. And then I'm going to continue on, and I'm going to get 2Fe plus 3 aqueous plus my 3SO4 negative 2 aqueous. So going like this. So I'm just going to underline it so we know this is all my reactant side of it. The rest of it being my products. So this is the ionic, so it has each part, all of it, all together. Then it asks for my net ionic as well. So I'm just going to extend the page here, and I'm going to do it in blue so that we see it differently. So my net one is going to be what?
Cu.
3Cu 6Cl. Tracy? And that's the net one there. Sorry? Oh yeah, I'll get there.
I feel like I'm good with 6.
Is there anybody who needs me to do another one in 6?
Yes.
Okay, so if you guys want to do a couple practice ones for yourself and you're feeling good, and then join with us on 7. I'm gonna skip G, and the reason why I'm gonna skip G this is the actual second. I'm gonna skip G just because I know that both of them are soluble, so I'm gonna go to the J one just so that we have practice with it, okay? So, we're gonna look at J. So with my J, I have Na sulfite, alright? Plus calcium bromide. Just gonna be my swaps with sodium bromide. It's gonna then be with calcium sulfite. So then I need to look at my charges. I know that this is a +1. Sulfite is a -2. Calcium is a +2, and bromine is a -1. So +1, -1, and +2, -2. So crisscross are equal to 0. My 2's got to go here. My 2's got to go here. Therefore, I need to balance this, right? I have 2 sodiums and 2 bromides. Easy one to do. Just put a 2 in front of it. Are we okay with that? Kind of went through that part faster. This is just what we've done in the past. So now I need to look at my chart. So I'm going to look up bromine. Bromine's attached to a sodium. It's soluble, so that means that it's aqueous. Now we're going to look up the sulfite one. And I'm going to find out that sulfite hooked up with calcium is low solubility, therefore it's a solid.
Wait, how do we know it's a low? Oh,
Okay. So then what I'm going to do is I'm going to move into my ionic. Ionic is the really big long one. So I just look at it, there's 2 sodiums, 2 Na, my charge is +1. Moving to the next part, there's only 1 sulfite, SO3, with a -2 charge. Are we okay with how I'm going so far? Okay. Then I'm going to have calcium as a +2 charge, it's aqueous, plus bromine. There are 2 bromines there, it's a -1 charge, and it's aqueous. Then I'm going to do my arrow. I'm going to move to the other side. Starting in the first one, I again have 2 sodium, +1, aqueous, plus 2 bromine, the -1 aqueous plus my one that makes us solid, so calcium sulfite with the solid. Again, I'm just going to underline this one in red to just show that that was all on the reactant side. And the other part would be our product. Doing this part here, do we understand how we broke that down? All we're doing is looking up here, there's 2 sodiums, or 2 sodium with a charge. Sulfite is by itself. Calcium is by itself. Bromine had a 2, so we had to put a 2 in front. And I just kept going.
What's a dissociation equation?
That's when you were dissociating it before into its respective ions. You guys did all of that before. Your last assignments, the last stuff that we were working on. Assignments that you handed in with dilation and stuff like that, and before that, the handouts, it's all dissociation. Dissociation is when our compound that's dissolved in water. You want to look at the book when you see notes, you don't remember. So my next one here, my net one is going to be what? What 2 ions are going to come together to make me that solid? Ca and SO3. So Ca is there, plus 2 is an aqueous, plus my SO3 as a -2. It's aqueous to make me my CaSO3 as a solid. Sorry, it's kind of scribbled. And that's net ion. Is that a little better for those of us that wanted another one? They just get ignored. For a net ionic, we just ignore the spectator. Because what we really want to know is what are the 2 ions that are coming together to make my solid. And so that's why the spectator ones get ignored. Okay? So net ionic has no spectators, where ionic is everything. Spectators included. Alright, so we're going to look at 7 then. Alright, so we're on 7. It says, devise a procedure that will enable you to separate each ion from the other in the mixtures of the following pairs of ions. So we have chlorine and phosphate. Right, those are my 2. Alright. So we're wanting to look at this and we're wanting to see how we can pull them out in order to get one precipitate at a time. So it's like we're going to do 2 steps. So I write it as a 1 and 2 to show myself the steps. This one you have to do first and then the next one. So this is when you're going to use your yellow sheet. You're going to look up the chlorine and phosphates. We're going to find out hooked up with what, how can it get removed. So kind of a trial by error. So I'm just going to start with chlorine, because that's the first one written down. Okay, we're going to look up chlorine. So rule what is chlorine? Okay, so hooked with what is it going to create a solid? Okay, so I'm just going to write these. So we said Ag, Pb, TL, Italian.
Yeah, probably
Is that it? Yeah. Okay, so then all I'm going to do is I'm going to just look at phosphate for a second to see if there's any double ups. Because if there's 2 that would make me a solid, then I wouldn't be able to use it, right? So I'm going to look up phosphate. What rule is phosphate on? 10. Okay, which ones can I use here to make a precipitate? These are the soluble ones?
Soluble or anything like that.
Alright, so these are my solubles. I'll just write it this way. So we'll just look at them. H and what? NH4. Okay, so if I look at this, this means that there's lithium, it's not over there, sodium's not over there, potassium's not over there, rubidium's not over there, cesium's not there, francium's not there, hydrogen's not there, NH4 is not there. That means that all of these can be used to pull out my phosphate to make a precipitate. Do you get that? All of those can be used. But there's other items that are not listed that we could use instead, right? Because it says all others. Is that right? Okay. So in my world, I would just choose something that doesn't fall in this side for chlorine and pull that out first. Okay? So what is an element that doesn't fall over there that's not one of these that we can hook up with phosphate? Gold. Alright. So we can do gold. Doesn't really matter. So let's do gold. So gold is AU. What's our charge for it?
+3 or +1.
+3 or +1? Okay, so 3?
No, do 1. 1 be easy.
So what am I doing?
1.
I heard more 1, so I'm gonna
You want 1.
yeah. Okay. So we're saying that we're gonna have this one with our chlorine at first, because remember they're gonna mix or whatever, right? Something that's gonna mix to swap, right? To fade. So I'm gonna have AU with my Cl. You okay with this so far?
Yeah.
Okay. Then what do I want to have with my phosphate that's not gonna cause a precipitate here? Okay. It's Riverside Gold. So I would have chosen NCL or something, but okay. So what's my charge on this one?
+4 or +2.
Alright, so we're doing 2. Okay. So my PT is going to be with this PO4 -3. Oops, sorry. Okay. So I'm going to have to do my crisscross, right? So I'm going to get a 3 here and a 2 here. These ones are fine on their own. Alright. So now that we've created this, okay, we are going to swap them. So my AU is going to go with the PO4. And I have a -3 and a +1, so that 3's got to go there. And then I'm going to hook up our PT with our CL. I have a +2 and a -1, so my 2's got to go behind. Then I need to balance this large equation here. So I have 2 phosphates, 3 and 3 gives me 6 for my chloride, 6 over here for that, and there's 6 gold, so I believe that we're balanced like this, unless I made a mistake. So now we need to just go back and double check our things here. So our phosphate one here with gold is the one that would make me a solid, right? And this one here would be an aqueous. Correct? That's our first step, so that means that we pulled out to that one. So moving on to our second one. I just want to finish this one off so we're done. Then what am I going to attach with my chlorine? Could be anything. I'm going to go easy. I'm going to go sodium, just so that we know this. Okay, +1, -1. This is made aqueous. This time I want to hook it to one of these here, and I don't have anything to buddy it up with, so it's just going to be an ion on its own. I'm lazy, I'm going to choose the first one just so that we're done faster here. Ag is -1 aqueous. When it comes over, my two negatives are, +1. My two positives are switching. AgCl is going to make my solid. And I'm just going to have sodium floating about, enjoying life. And I'm going to be balanced. I'm done. Okay, so you have to do 2 steps in order to make it work. You can choose any ones that you want. I honestly looked at the easiest one that you can do.